So on this problem, NS and SP are tangent. So since they're both tangent lines to the circle and they meet at a common point, those two tangents are going to be congruent to each other. So I'm going to set them equal to each other. 2x squared minus 4x equals x squared minus 5x plus 6. I want to move everything to the same side of the equal sign. So I'm going to subtract x squared, add 5x, and subtract 6 from both sides, which will give me x squared plus x minus 6 equals 0. And then I'm going to factor that. I'm going to come up with two numbers that multiply to give me -6, but add together to give me +1. So that would be x plus 3 and x minus 2. And so when I solve, I said both of those factors equal to 0, and I get x equals -3 and x equals +2. So if I plug in -3 and I square it, then NM is 9. And if I plug in +2 and square it, then NM is 4. So there's actually two answers that work. And you can even go plug these back in to NS and PS. Oh, you do need to plug them back in. Sorry, you do need to plug them back in for NS and SP and make sure that they make sense. So when you plug in -3, 2 times -3 squared minus 4 times -3 gives you 30. And when you plug in 2 times 2 squared minus 4 times 2, you get 0. So even though, like, when you plug in 2 for x into NM, it makes sense. When you plug 2 in for NS, it gives you 0. And you can't have a segment that has a length of 0. So x equals 2 actually doesn't work. So x is equal to -3. And again, just because you get x is a negative number doesn't necessarily mean it doesn't work. Because here, you're like in both instances, you're squaring that negative and it becomes positive. So don't just assume because x is negative, it's automatically eliminated. Okay, the next thing we want to find is MS, the length of MS. So I'm going to draw that in. And then I realize NM is my radius, because M is the center of that circle. NM is the radius, and S is a tangent line. And we know that when a radius intersects a tangent line at the point of tangency, those two segments are going to be perpendicular to each other. And we created the best shape in the whole world, a right triangle. So because we know that x is -3 and we go plug it in for these expressions, we get NM is 9, NS is 30, and we're looking for our hypotenuse MS. We can use Pythagorean theorem to find the length of MS. So 9 squared plus 30 squared equals MS squared. And when you solve that using Pythagorean theorem and take the square root, you get MS is 31.3209, so 31.3. And then finally, we want to find the length of the arc in QP. So that's where we're going to need to take this. This is where you really have to push yourself and think critically. So in order for me to find the length of that arc, I need to know the measure of that arc in degrees. And so I need to know the measure of this angle. So I don't really know how to do that, but I do know that in a right triangle, if I know 2 out of the 3 sides, I can use inverse trig and find a missing angle. So I'm going to find the measure of angle in MS by using inverse trig. So that's my angle. That's my opposite side is 30. My adjacent side is 9. So I'll use inverse tangent or tangent inverse. So tangent inverse of 30 over 9 will give me that theta, that angle. And if I type that into my calculator, I'll get 73.3 degrees. So this angle right here is 73.3 degrees. This angle is also going to be 73.3 degrees. And so to get the measure of this big section of my circle, I'll subtract both of those angles from 360 and get 213.398 degrees for that big, large angle. So to find the length of this arc, I'll do arc length over circumference. Equals the arc measure, which is in degrees, over 360. So our arc length, we don't know. Our circumference is 2 times pi times the radius, which the radius is nm, which is 9. The arc measure we just found was 213.398 degrees over 360. And so when you cross multiply and then divide off the 360, you get the length of the arc rounded to the nearest tenth to be 33.5. And there's no units on this one, so we're good to go.